All right, everybody. Welcome to my weather and climate office hours. Slightly later afternoon edition this time around. I'm going to play around with a few different times, see when people are able to make it most consistently. Maybe do some alternating weekly timings, early versus late in the day, and on different weekdays to accommodate as many folks as possible. At least for the scheduled sessions. Some of these, again, are sort of ad hoc, last minute, based on events as they develop. This is one of the more uh, regularly scheduled sessions, given the lack of extreme weather, although it has still been active in California, and we'll talk about that today. Also, want to recap the season a bit for California and the western U.S. broadly, and think about what might be coming next, both in terms of this year's water supply, this year's wildfire season, in light of what's already happened, which is something we already know, and what might happen in the next 3 to 6 months with the likely transition to a strong La Nina event. And then I can answer some questions in addition to those topics, potentially related to the Ask Me Anything session last time, if there's any lingering questions regarding some of the discussion that we previously had on the recent rates of global warming and the unprecedented global warmth we've seen so far in 2023 and continuing now into 2024, and a lot of the conversation and speculation and some quantification of exactly how large the margins are by which we're breaking these global records, and what that might mean for our current and present trajectories. So I don't think I have any transformationally new thoughts since last week on that topic, but if there were lingering questions, because I know there were a few, feel free to add those in the live chat, and I'll answer those at the end of the session after everything else I just discussed. So the active weather pattern continues in California. In fact, in Southern California, it was a very active weekend, as well as parts of Northern California too. Yet another system characterized by rainfall and precipitation broadly that was sort of patchy. Some places saw a lot more than others, but locally very intense and heavy, and importantly associated with thunderstorms. This was yet another thunderstormy storm in California, and that's not especially common historically. I do think we tend to forget that there have been years historically that have been characterized by a lot of winter and spring thunderstorm activity, but it certainly doesn't happen every year, and we've now seen a few years in a row where we've seen a notable predominance of convective precipitation types, and also, in particular, very heavy 1 to 3 hour or even sub-hourly downpours in urban areas that have resulted in uncharacteristically significant flash flooding in those places. Once again, the Santa Barbara, Ventura counties coastal sections were hit hardest this weekend with some of these slow-moving thunderstorms that produced flash flooding, closing Highway 101 and causing cars to float down it for like the third or fourth time in almost as many years. Remarkable number of significant flood events along the Central Coast in recent years continuing. This one was more localized, and fortunately not as catastrophic as some have been in the past, but it was still notable. By the way, some of these thunderstorms in recent days have been producing frozen precipitation types at the surface, including significant amounts of frozen precipitation that, on top of these localized floodwaters, have accumulated as the floodwaters have receded and caused drifts of frozen precipitation. I'm being deliberately vague about what kind of frozen precipitation, because there's been a lot of sharing on social media of photos showing heavy snowfall in Santa Barbara, for example, or in central Santa Clara County this past weekend with thunderstorms occurring. Of course, none of this was actually snowfall, which requires surface temperatures to be at or at least close to freezing. Instead, it was hail. And as I've talked about before, you can get hail at surface temperatures far above freezing. In fact, some of the most dramatic hailstorms on Earth occur in summer in fairly hot places where severe thunderstorms develop. So we're talking, think Texas in July, or the Great Plains or Florida in late spring. Those are not cold places by any means. They're actually sometimes miserably hot and humid on the same days when you get these massive hailstorms. So hail is frozen because it forms at very high elevations in the atmosphere where it's always well below freezing. And it forms these rather solid icy balls that can essentially make it to the surface even when it's well above freezing by virtue of how dense and how much frozen water is accumulated in them. Essentially, if you chuck an ice cube across the room, even if the room temperature is much above freezing, it doesn't exactly melt by the time it reaches its destination. So you pull it out of the freezer in an environment that's much colder. Think of that as the middle to upper atmosphere. And it takes a while for that ice cube to melt, even if you put it on the kitchen counter or in the sink. Think of that analogous to the hailstones falling through the cloud, through the cold layer into the warmer layer, and then landing on the surface and sitting there and accumulating. That's what we've seen a fair bit of with these thunderstorms. So the lacking ingredient actually isn't super cold air at the surface for these sorts of events in a place like California. It's actually the requisite instability to produce the thunderstorms that can yield this kind of hail. And I say this as I look out the window right now here in Boulder, Colorado, and see the current precipitation type has changed over to graupel, the meteorologist's frozen precipitation type bane in some ways, because it's a rather complicated thing to describe. Graupel is technically distinct from hail or snow in the sense that it is probably closer to snow. It's essentially snowflakes that melt a little bit on their way down, but then refreeze essentially with a hail-like outer structure. So it's variously called hail, a soft hail, or graupel, or snow pellets. Essentially, it's these chunky Dippin' Dots ice cream like texture frozen precipitation that kind of falls apart when it hits the ground. So it's not big solid chunks of ice like hail can be. Graupel is never damaging because it's soft. It's also can occur at temperatures at the surface warmer than freezing as well, because again, it's that solid outer layer of ice gives it some protection from rapid melting. So currently it's graupeling at about 40 degrees where I am. It's usually a bit colder when you get graupel, but it need not be cold at all at the surface to get hail. So just a crash course in frozen precipitation types, since I've seen even state agencies saying that it snowed in Santa Barbara, and that is very far from the truth. That would be truly extraordinary had it happened. Notable that there was accumulating hail, but not nearly as meteorologically improbable as it would have been if, in fact, there had been accumulating snow near sea level in Santa Barbara, which would have required temperatures colder than we've seen in many, many years in that part of the world. That did not happen. What we did see was hail and flooding, which in some ways is even more disruptive, but less meteorologically historic, let's call it that. But there have been a lot of thunderstorms around. They've been kind of scattered, so as is the nature of convective showers, those cumulus congestus and cumulonimbus clouds that produce those heavy showers and thunderstorms, they're not uniform. Some areas see these intense downpours of hail and rain and flooding and lightning, and other places see very little at all. In between them, it might even be partly cloudy or sunny. And a lot of folks, once again, are saying this came out of nowhere. The meteorologists failed to predict this, which, again, as I've talked about in several recent sessions, I'll remind folks is just not true. This was in the official forecast by the Weather Service every single day it happened, and also it was predicted by the weather models every single day it happened. It may not, however, have shown up on your smartphone weather app for a long list of reasons that, if you're interested, check out my previous live office hours, and I'm sure I'll have another roundup of that again in the future. So it's been a showery pattern, a convective pattern, some snow in the mountains, some rain near the coast, lots of thunderstorms scattered about in between, even some severe thunderstorms. All in all, a pattern that is not tremendously unusual for late March, early April, but is somewhat unusual for the preponderance of thunderstorms, essentially. That's really the only piece of this that's somewhat remarkable. But the other piece that's remarkable in a cumulative context is what it means for the accumulated seasonal precipitation in parts of Southern California, where downtown Los Angeles has now reported its wettest back-to-back water years in over a century of record keeping. I believe there's one pair of consecutive water years in the late 1800s that was slightly wetter But because the water year doesn't end until September, there's actually a decent chance that with any additional precipitation this spring or any brief isolated summer downpours, we may well end up with the wettest consecutive two water years on record in downtown LA and therefore in other parts of Southern California as well. So this will have been an extraordinary pair really, of two record or near record wet years in some parts of California in the same decade where we've seen our worst drought and our driest years on record in most of those same places. Again, that's a theme I keep harping on because I really do think it's a harbinger of California's climate change future, which looks a lot warmer but with a lot more hydroclimate whiplash in the mix as well, certainly as we've seen this year. Most of the California coast, in fact all of the California coast, remains wetter than average for the season to date, so that's where we're going to end up the winter. Pretty impressive season, more so in the south and the north, but still wetter than average along all of the California coastal regions this year. Progressively less anomalously wet as you go inland, and in fact there are some parts of the Sierra Nevada that are slightly below average, their seasonal average precipitation, but not greatly below, and in fact this, in a bit of a reversal, the snowpack is now in relative terms a little bit higher relative to average compared to total precipitation because of the very heavy snowfall we saw in February. So the statewide snowpack percent of average is right around 100 to 105% of average. So a remarkably unremarkable number there for the April 1st total. Slightly above average, about 110, 115% above average in the northern Sierra, and about slightly below, about 90% of average in the southern Sierra. But all in all, those are pretty healthy numbers. We're not going to have to worry necessarily about the residual runoff and outflow from the Sierras this year, in the sense that we're already on the heels of a really wet year, and this year was sufficiently wet in the mountains that it doesn't really change the big picture. And along the coast, it was actually wetter than average again, and so there things will be nice and lush and green. So from a short-term water supply problem, we're not going to have major issues in California in any of the major watersheds for meteorological reasons. I say that almost as a Murphy's Law affirmation, so that there aren't non-meteorological reasons why we have water supply problems in California. And of course you can imagine things like earthquakes and wildfires might be included on that list, but right now, meteorologically speaking, we're not in a short or medium-term drought in California. We won't be most likely between now and at least the fall, and in most of California it would be pretty hard even to get into a drought through the autumn, just riding on the coattails of what we've seen last year and this year. A little bit more hesitant to make that claim about next winter, though, for reasons I'll talk about in a little bit. But all in all, this is a pretty good, the water situation this year, not overly concerning this year. There's a much lower risk of spring floods this year. There's not a massively overabundant amount of water in the Sierra snowpack this year, so this is a near average year snowpack-wise. Last year, we had more than double the amount of water that we currently do in the Sierra, so this is not a bad snowpack year after all in the mountains, and yet it's still about half or less than half, maybe 40% of the amount of water we had up there last year. So kind of a good situation to be in that sense, not really a tremendous risk of downstream snowmelt flooding this year, unless we get some insane late season warm atmospheric river or some super persistent heat wave, neither of which looks particularly likely, or certainly nothing like that is on the horizon for the next couple of weeks. So probably not a notable risk of snowmelt flooding this year. Never say never, but it certainly looks a lot lower than it did last year. I don't necessarily expect to see a reemergence of Tulare Lake more than the localized ponding that has occurred this year. So that's pretty good news. And then from a wildfire perspective, there's two pieces to this dynamic. One is this is the second wet year in most parts of California with a decent snowpack, a decent or better snowpack, second year of that as well. So what I would expect to see is a pretty slow start to the season in most areas. So I wouldn't be too surprised if May, June, maybe even into July in some parts of California, see near to below average fire activity. But then starting later in July and into August, I would expect to see an increase in activity in what are known as vegetation limited regimes. So these are places where it's always pretty dry, certainly dry enough to burn late summer and early autumn, but where there's not always a lot of vegetation to burn, or there's not sufficiently contiguous vegetation or dense vegetation. We're thinking places like grasslands and chaparral, scrubland, and the deserts. So by late July, it's quite possible, if we do heat up, as is likely, that we'll start to see a significant increase in fire activity across much of Southern California, including some areas that don't always see a lot of fire activity. So that's going to include parts of the desert regions, which now have had 2 consecutive wet years, and where that's going to allow some of those invasive grasses to really fill in the gaps in between the sagebrush and the Joshua trees and the other desert vegetation, depending on where you are. So that may increase the likelihood of some fires in the deserts themselves earlier in the season. That might be where we see the risk emerge soonest this year, kind of as we did last year, to the extent that it emerged. And then later in the season, again, this has been a wet year, but it has not been in Central and Northern California, and in the Sierra in particular. It has not been an exceptionally wet winter this year. So last winter was exceptionally wet almost everywhere. This year was exceptionally wet in parts of Southern California, but not so much in other parts of the state. We also expect there to be a significant increase in the relative anomalousness of warmth later this summer. So we've been kind of cool recently. That may continue for a couple more weeks on and off. But then by the time we get toward June, July, August, and in particular August, September, and into October, so late summer into early fall, which is usually when California's fire season peaks anyway, in terms of flammability and offshore wind conditions, that's when the transition toward La Nina might really start to ramp things up. So I would expect to see a near to slower than average start to the season, and there'll probably be some headlines in July proclaiming that California is seeing yet another quiet fire season, which will then end up potentially being looking silly, a little bit silly in retrospect, when things pick up potentially quite a bit in August, September, and October. So I would expect there to be a greater than average ramp up between the first and second half of fire season this year. I think it's going to be potentially much more active in the late season this year than it was last year. Wild card, as always, is if we get another August or September tropical storm landfall that brings widespread rain. Well, that'll certainly defuse the situation, and that's always a possibility, but it's out there in the tail. There's really only a 5 or 10% chance that happens in any given year. It happened last year, and we were already lucky on the heels of a wet winter, and then we got that, which really decapitated fire season. Unless that happens again this year, I would expect this August through October to be a lot more active than last year, particularly because there is a signal for a rapidly developing La Nina event now in the tropical Pacific, as El Nino is in its very last days. By autumn, we may have a moderate to strong La Nina ongoing, and there are already early indications that we could see a pretty hot and dry autumn. And I want to remind folks that even after wet winters, we've seen major and sometimes catastrophic wildfire activity. A good example of this is 2016-2017, and I don't need to remind folks up in Northern California, particularly up in the North Bay, what that season was like. 2016, the winter that preceded it, was 2016-2017 ended up being the wettest winter on record in some parts of Northern California, and was followed by the most destructive fire season on record in much of the state, especially up north. That was the year of the Tubbs Fire and the North Bay fires, along with other destructive fires in northeastern California foothills. So, and that occurred primarily because we had a very wet winter and a cool spring, relatively cool spring, massive amount of vegetation growth, as we'll probably see this year with favorable growing conditions, a very wet winter in many spots and some mild conditions in the spring, followed by a very hot summer. In fact, that summer ended up being the hottest summer on record in some of the same places that it was the wettest winter on record that preceded it. That was a particularly nasty combination for wildfire risk, not necessarily in the high Sierra so much, but in the low to mid elevation zones, places where there's more grass and brush and where there's more year-to-year variability in how much vegetation growth there is. So that year was kind of a worst of both worlds combination of wet enough to grow a lot of extra vegetation and hot enough to dry all of it out by the end of fire season without any early season rain. So that year we had very strong offshore wind events, very dry autumn conditions following a very wet winter. We actually saw a very serious fire season, but it mostly waited until September and October to really get going. We could see something similar to that this year in terms of the background risk. Now, that is not a prediction of catastrophic fires. It's just saying that the sequencing between this year into this autumn, they remind me they're fairly reminiscent of that potential transition from a wet winter, even a very wet winter in some spots, to a warmer than average summer overall, to a dry autumn. That is a plausible sequence this year, and it would mean that the first half of fire season is going to tell us very little about what happens in the latter half, or especially the last third of the fire season. Wild card being, do we get an early season rain event that helps us out? That always is sort of a wild card. Or do we get early season offshore wind events in August and September that really get us off to the races, or a major dry lightning event? That's a wild card in the opposite direction. So it's not a specific prediction of a bad fire season, because of course you can have a lot of fires that burn a lot of area without it being a particularly serious fire season if those fires are not moving into populated areas or not burning at extremely high intensities. But this is the kind of situation where I would think that the dynamics are more complicated. It's not as simple as severe drought equals the worst fires on record. That's true, perhaps, to a certain extent in primarily forested ecosystems. But in some ways, it is transitions between very wet conditions and very dry and hot conditions that can result in some of the most explosive fire conditions. And we'll see if that happens this year, but this could be a year where that alignment is somewhat favored. So it's early, it's April 1st. I wouldn't worry about it. There's going to be probably a very nice spring ahead. There's going to be an opportunity for a lot of prescribed burning, potentially, if folks and agencies get their acts together over the next few months. In some places, it's probably too wet to burn right now, but that will change in the coming weeks, and conditions vary, of course, quite a bit locally. So there should be a good, probably at least a 2-month window, at least in terms of meteorology and fuel moistures right now, and maybe a 3-month window in some spots to put some good fire on the ground before what could be a transition once again towards a more active fire period, both potentially from this autumn and moving forward if in fact next winter ends up being drier than average, which would potentially be the case if we see a particularly strong La Nina event next year. That's really getting ahead of myself, but it's just sort of my thinking as to what might be coming down the pike. It's pretty hard to put numbers on it right now, but I think that we shouldn't expect this year's transition into next year to look like last year's transition into this year. Let's just put it that way. So that's mostly what I wanted to cover about the season so far, what's coming, and what the months ahead might hold. One thing I will add is that it does look like there's going to be an active weather pattern continuing this week in California. So one more notable storm. This is not going to be a storm that has a really well-defined rain shield or cold front associated with it. In fact, some folks may see a dry, windy cold frontal passage with maybe just some scattered showers that miss some people completely and give other people downpours, but windy and cool conditions across a broader area. But then it'll be followed perhaps by an unstable air mass. It may sound familiar, with a significant amount of atmospheric instability. It looks like some wind shear and upper level diffluence. These are essentially it's a pattern that's favorable for thunderstorms once again. So even though there won't be a dramatic cold front necessarily, the post-frontal air mass will be quite unstable in the cold core of this low as it slides north to south across California. And this actually looks like a potentially even more favorable pattern for thunderstorms than the last couple of storms. So the likelihood of seeing at least a few isolated supercells or severe thunderstorms with some significant hail accumulation or a brief funnel cloud or tornado looks like it's actually going to be higher with this next system than the last one. So we got another system that's going to produce some thunderstorms, maybe some dramatic clouds and some dramatic weather in California, and inevitably more complaints that the meteorologists didn't put it in the forecast. And then it came out of nowhere. So you're hearing it from me now. So one more of these systems, it actually could drop some snow showers down to pretty low elevations up in northern California, maybe some brief convective snow down to 2,000 feet or so. Again, far from unheard of for late March, early April, but notable nonetheless. And I think the more notable thing will be the prevalence of interesting and dramatic looking clouds and some potentially stronger thunderstorms once again later this week as that system swings through. After that, there are indications finally that California will warm up again, and it will be warm, by the way, in the meantime. A couple of warm, dry days right now before this cold, thunderstormy system later this week comes through, and then probably warmer and drier conditions again after that. So this is definitely a spring rather than a winter pattern, but I'd call it an active spring pattern. Sometimes we have pretty calm springs, sometimes we have pretty active springs. This looks like so far it's been a pretty active spring, and it looks like it'll continue on and off in April. Certainly this one notable system this week, and maybe a couple of weaker ones later in the month. We'll just have to see. Doesn't look like anything dramatic at a large scale, but again, if you're under one of those strong or severe thunderstorms, they're not widespread in these patterns, but they are isolated, scattered around the state. You can get localized flooding or accumulating hail or even a funnel cloud or tornado or two, as we've seen multiple times so far this year. So that's the pattern coming up. Probably will keep snowpack about where it is. It'll about balance melting with accumulation, so we'll probably stay right around or maybe slightly above, like 101 to 105% of average on a statewide basis for the next couple of weeks. That would be my guess. All right, so that's about halfway through. I'm going to start taking a look at the questions here. I'm going to take a sip of tea. You may see a brief commercial break, but that'll be done in about 10 seconds. And I will start going through the questions. Good opportunity to add some, by the way, if you haven't added them yet, because there are only 5 or 6 so far. So your odds of getting answered are higher than average, let's put it that way. So just give me a minute here. All right. So, the first question is, that's interesting, the best place to view the April 8th eclipse. Well, there's all sorts of tools. NASA's got a good graphical interface. You can see the arc path of the eclipse over the continental U.S. from Texas through, I think, upstate New York, through parts of the Northeast. Weather is actually going to be a challenge for a lot of folks who are trying to view the eclipse, especially in the southern half of its continental U.S. arc. In fact, there might be a severe thunderstorm outbreak in Texas for folks. So on the one hand, it's possible someone's going to get a tornado during the eclipse photo, which would be definitely a once-in-a-lifetime kind of opportunity. Or alternatively, there could just be a pretty solid layer of clouds down there, and it might be difficult to actually see the eclipse in some places down there. So high risk, high reward kind of viewing situation, I guess. There are a bunch of forecast tools out there, a bunch of weather model websites showing the path of the eclipse along with a cloud map from the different models. It's still a little bit too early. It's still a full week out to know exactly where the clouds are going to be, but I would check probably the day or so before. And if you are chasing the eclipse, it probably is worth thinking about being able to be mobile along at least a couple 100-mile axis of it the day of, because your viewing opportunity may be much better just 100 miles up the road, depending on where the clouds end up lining up. So I would consider the cloud forecast. There's a bunch of cool tools out there to do just that. I believe there is a until the eclipse is over, that pivotalweather.com has a, which I occasionally use, has a permanent eclipse track arc superimposed across all of its weather maps. So that's one way to take a look at it. And again, you will see the partial eclipse in California. I think it'll be about a 25 to 30% of coverage in California when it occurs. So, and the conditions, granted, it's not as dramatic as a total eclipse, but I think that viewing it in California will be reasonable. The partial eclipse, because the cloud conditions, I think right now are looking like it should be relatively clear. Although again, if you're in California and viewing the eclipse, you have to use eclipse safety glasses, because not enough of the sun is obscured to prevent you from burning your corneas with that solar radiation. So don't look at the sun if you're in California, unless you've got eclipse safety goggles. You can always look at the shadows that it produces on the ground. That's one way to see an indication of it. But unless you're in the actual 100% totality path, the only exception to the time you can look up at the sun without burning your eyes, potentially permanently, and blinding yourself. So unless you're in that eclipse arc, and you'll know if you are, don't look at the sun. That may sound obvious, but every time that there's an eclipse, there are a large number of people who get essentially life-altering eye injuries. So it bears repeating, since it happens pretty much every time there's been an eclipse in recent years in the U.S. Yes, folks commenting that in Central Coast right now, it's very nice. It's in the mid-70s, partly cloudy and glorious. Yeah, I mean, this has been a springier spring in some ways than California sometimes sees. More changeable, genuinely warm days with some genuinely stormy days in between. Doesn't happen every year, but if it's going to happen, this is the time of year when it would happen. So in that sense, it's the quintessential spring. Ron asks, are strong La Niñas a portent for dry, warm winters? That's a complicated question. There is asymmetry between El Nino and La Niña, so a strong El Nino is more predictive of a wet winter in California than a strong La Niña is of a dry winter in California. That said, it is predictive of persistent ridges over the Gulf of Alaska. The problem is sometimes those ridges are just far enough away that we end up getting a bunch of cold, wet storms instead of really dry conditions. So that's the needle we're going to have to pay attention to, that this pattern might end up threading next winter. But generally, there is a correlation between strong La Nina events and ridging over the northeastern Pacific, which tends to, more often than not, favor drier conditions, but that's not a slam dunk. It does not really favor warmer winters. It's just that global warming is making all winters so much warmer that and also winters that are dry in California tend to be warmer winters, as for reasons you might expect, more ridging, warmer temperatures at the surface. So mainly that warmth signal is now just coming from global warming. It's kind of overwhelming the El Nino La Nina cycle, the natural cycle. The precipitation signal, of course, we're still getting some significant intriennial influence from ENSO, El Nino, La Nina oscillations, but we're also getting increased oscillations from climate change there too. So El Nino, La Nina aren't the total story. We got climate change in there too, and we've also got a lot of sort of random variability that isn't explained by either of those things. So again, no specific prediction yet for next winter, but yes, a strong La Nina would result, especially again in central and southern California, in a tilt in the odds towards a drier than average winter on average. Not every time. And historically, the temperature pattern is a bit different, but in a warming climate, it would probably be a warmer than average winter on top of it. So there may be a strong relationship actually between dry autumns in California, interestingly, or we don't really tend to see early season onset of precipitation in some of these strong La Nina years. So that might be something to pay attention to from a fire season perspective, because when that season-ending rain first occurs is actually a pretty big deal. Even if it's only, a few tenths of an inch or an inch of rain, it's a big deal from a wildfire perspective. Let's see. I'm still here. There's no gap in the coverage. I'm just reading the questions as they come through. All right. Well, there aren't too many questions coming in, so I might briefly then expand on some of the discussion I had in the last session on why the world is so warm right now, and in particular this sort of public conversation about why there's been such a dramatic shift in the last year or two, in particular towards record-breaking temperatures. And there's actually a link that I'm going to share with folks in the comments right now, and for people who want to dig into it, I think it's this is a blog post by Andrew Dessler, and he's a fellow climate scientist who does a great job explaining different things at times. Well, he always does a great job explaining things. The at times was just the explanations are periodic. Also, my camera is doing some light adjustments, so let me quickly go turn on a light. So here's the link. You can check it out, and I'm going to go wheel myself back to the light so I can switch it on. This is the risk occupational hazard of doing a late in the day on a cold gray day kind of talk. So what we've got is a planet that has warmed rapidly in recent months, even relative to what it was a year or so ago. And now I have another lighting problem, so let me just bring in. Okay. Usually I can get away with just using natural lighting in here, but apparently it's gotten dark enough that's a bit of an issue. So 2023 was the warmest year on record. 2024 has, to date, surpassed already 2023 in some ways, so it's even warmer. In some data sets, 2023 ended up being the first year at or near 1.5 degrees centigrade above the pre-industrial average. That does not mean that we've exceeded the 1.5 degree temperature target as described by the IPCC. You hear about that all the time. That was a multi-year target. Our multi-year warming is still below that level. Nonetheless, it is a significant, it's a meaningful level of warming because it means that we're getting awfully close, even by the IPCC's definition, and it's probably going to happen, I think, within the decade for sure in terms of that multi-year average. But the point being, 2023 was a ridiculously warm year. 2024 so far remains ridiculously warm, perhaps even a bit warmer than last year. But now, why was 2023 so ridiculously warm? And the main reason for that is global warming, human-caused global warming due to the accumulation of greenhouse gases over the past century or so. Probably 85 to 90% of the reason why we were as warm as we were. 5 to 10% of the reason why we were as warm as we were is probably due to El Nino. El Nino does unearth some of that extra warmth that's stored in the global oceans and transfers it to the atmosphere. So we have warmer atmosphere and also warmer surface ocean rather than the subsurface ocean. So the cumulative anomalous warmth in 2023 is mainly due to a combination of predominantly global warming. Then we have El Nino. But then the question of why was there such a big jump in temperatures between 2022 and 2023, 2024 is a slightly different question, because global warming did not itself suddenly accelerate between 2023 and 2024, to the best of our knowledge. So what did happen? Why were we so much warmer in 2024, 2023 relative to a couple of years ago? And the answer has been a bit of a point of contention in public spheres, even in scientific spheres, which is a bit unusual. There is some genuine conversation surrounding this. But I think one of the most important things to realize is that if you look at 2023, even if you just consider 2023 and ignore the multi-year average, we're still right around where we would expect to be on this multi-decadal warming trend according to where climate models said we would be in 2023 and 2024. We're in the between the right near the median and the upper 2/3 of that distribution of the range of potential temperatures right at this point in history that was predicted by these climate models. So I don't think it's accurate that the warming has been faster than predicted. I just don't think that's a quantitatively supported statement. Even though some people have made it, some newspaper headlines have said it, I think it's factually inaccurate that the warming that we've seen so far is faster than predicted. It's actually remarkable how spot on the money it is. And the reason why I shared Andrew's post here is he actually specifically looked at, okay, between 2020 and 2030 in climate models, which is of course the decade we're living through, what is the range of degrees by which in the model the Earth's temperature breaks the previous record? Essentially, what is the distribution of record-breaking margins? Not the actual temperatures, but the degree to which a given year exceeds all previous years in the prediction. And interestingly, the margin by which 2023 exceeded the previous record is right in the middle of the distribution of record-breakingness predicted by climate models. And that's a little bit wordy and technical, and there's some statistics involved, but really the point is, even not only is the actual temperature value from 2023 right in the range of where climate models said we should be at this point, but the degree by which it broke the previous record is also in the middle of the distribution of the margins by which the climate models say we should be breaking records at this point in history. And again, I don't think any of this is particularly reassuring. In fact, it's alarming, because what it means is that the models correctly predicted that warming would begin to accelerate a little bit right around now. And it does appear that the warming perhaps is starting to increase at a slightly increasing pace relative to what it was a few decades ago. But that too is not outside of what models predicted. We expected that to happen, partly because we're getting rid of these aerosol emissions, which were otherwise masking some of that warming. So the good news is we're cleaning up the soot pollution in the atmosphere. The bad news is that's having a side effect of unearthing some of the warming that had already occurred in the background due to greenhouse gas accumulation, because the aerosols were reflecting some of that sunlight. Now that they're not reflecting some of that sunlight is coming in, being subjected to that increasingly dense and thick layer of greenhouse gases, and it's trapping more of that outgoing terrestrial long-wave radiation. In other words, it's not because the rate of warming is predicted to accelerate right around now, not so much because the rate of carbon emissions is accelerating, but because the offsetting influence of aerosols is now decreasing as carbon emissions continue to increase at roughly the same pace they have been now for some years. So we've never been emitting more carbon than we are today, but that level has sort of leveled off. Now, that itself is also not good news, because what we need is not to level off our carbon emissions, but to bring them close to zero if we want to stop global warming. But the bigger picture here is that from what I can see, and from what a lot of other climate scientists have assessed, the warming that we've seen up through 2023 and even 2024 is not itself unexplainable by factors that are accounted for in existing climate model simulations. That doesn't mean that something weird didn't happen in the last few years. There have been some interesting insights into the pattern of warming, and the fact that we did see a particularly big jump. But I'm not overly impressed with the evidence that 2023 tells us something fundamentally different about the way the world works than in other similar jumps, or arguably other similar non-jumps. So if anyone remembers the pause, global warming ended in 2005, and then it ended in 2010. I mean, we just stair step upward. There's natural variability. There is natural warming and cooling. It's just that the human-caused warming is overwhelming those natural variations in the long run. So we end up just sort of stair-stepping up over time. We're really good at predicting the long-term linear trajectory. We're not so good at predicting those stair steps, because some of them are random and chaotic, and perhaps not that predictable. The question is, was there something in the system in 2023 that would have been predictable for this really big stair step up that we saw? And again, as Andrew points out in this post, I think the real tell is going to be, does this persist into beyond this year? If we transition to a strong La Nina event, as it looks like we likely will, global temperatures should at least start to level off a little bit. 2024, because of the warmth that we've already seen up through April 1st, it may end up being a contender for the warmest year on record, but it should not shatter last year's record. And it may well be slightly cooler than last year, depending on how things go. If, however, 2025, which should be cooler than last year based on this La Nina development, if it ends up being warmer than 2023 and 2024, then I think the evidence that something weird or something even more alarming is occurring would increase. That's a conditional, though, and I don't personally think it's likely. In fact, I think it's much more likely that 2025 ends up being cooler than 2023 and 2024, and we hear all of these denial headlines about how global warming ended again in 2024, which of course it will not have ended in 2024. I can tell you that right now. But I think there is interesting science to be done. There is some genuine debate, and honestly, it is interesting to see some of the conversations that are going on behind the scenes regarding the potential influence of that marine aerosol regulation change, which occurred in 2020, where there was a bit of a step change, where there was a sudden decrease in sulfur aerosol emissions from ocean-going cargo ships specifically. We will just have to see what the data show on this. There isn't really any compelling scientific evidence yet as to what the magnitude of that influence would be, except that previous studies, reading between the lines, suggest it should be pretty small. And that's what I've talked about in previous conversations. If future research shows that in fact it was larger than expected, or that at least regionally it was more important than some folks have assumed, that will be important and interesting science, and might not be very good news about the future, because it would mean that perhaps the aerosol effect in some places is a little bit underestimated, which could potentially result in a slightly faster rate of warming. But I don't think it's something that upends climate science. It's a matter of proportionality and degrees, and right now there's not a great deal of evidence that there's anything earth-shatteringly unique about 2023 in terms of the drivers behind the warmth. Unfortunately, it's mostly exactly what you would expect it to be, which is long-term warming caused by the greenhouse gas accumulations in the atmosphere, plus a boost by El Nino, and maybe a much smaller boost by a couple of other things that happened over the last few years. That's still really how we're thinking about it, and it didn't push temperatures beyond levels that climate models suggested that we would be at about halfway through the 2020s. So on the one hand, that's not good news because that's a heck of a lot of warming. I mean, yikes. And in fact, another interesting point in Ender's post is that there are actually, in the climate model world, years where we break records this decade, model years, hypothetical simulated years, where we break records by a much larger margin than we did last year. So if last year we broke a margin by about 0.15 to 0.2 degrees centigrade, and there's all this hubbub about that, there's some climate models that say that there are at least a small chance of breaking a record by 0.3 or 0.4 degrees centigrade sometime this decade. Yikes. What would that look like? That would give us a year with, 1.8, 1.9 degrees centigrade above average. So it just goes to show you that there is a lot of the system can throw a lot of variability at us on its own, even absent climate change. But climate change really ups the ante. I mean, it's that classic analogy where it makes it easier. It's like adding an extra number or using a weighted die. It's instead of using a six-sided die, now you have 7 or maybe 8 sides, and you have higher and higher odds of hitting your historic maximum values, and you also have at least a small chance of hitting something that you've never seen before at the very high end. If you have a pair of dice and you can't roll higher than a 12, traditional dice anyway, but if you start adding extra facets to your roll, then you can actually start rolling higher numbers if you get lucky or unlucky, as the case may be, depending on the context. So anyway, I think it's time for me to look and see if there's any other questions that came in. In the meantime, relevant to what I was just talking about. Oh yeah, folks commenting that the incoming storm is fairly cold for April. Yeah, it is definitely fairly cold aloft. It's not necessarily extremely cold at the surface, but at upper elevations, in the atmosphere, it is. And that's partly why we'll see thunderstorms. It's that strong decrease of temperature with heights called steep lapse rates, a bit of a tongue twister, that results in increased surface-based instability and under favorable conditions, thunderstorms, which I think we will see later this week. A question about my own personal support for these office hours. Well, so I have nothing is formal yet, but I'm hoping there's some ongoing conversations within the University of California. I think there's a path forward. But nothing's in writing yet, so I don't want to, again, hedging against Murphy's Law, I don't want to jinx it. I don't want to put anyone on the spot either, because I know sometimes it's a little bit sensitive to talk about the details, so that's all I'll say for now. So I'm optimistic, but technically, nothing is on paper yet. So there is still something of a cliff in July, but there is a path toward a turning away from the cliff. Let's put it that way. So my fingers are tightly crossed. I can talk about Pacific Northwest and Western Canada wildfire risk later. I'll do that later in the spring. Yeah, Noah mentions that Andrew Dessler's textbook, Modern Climate Change, is really good. It is. In fact, I think, I'm pretty sure I have it on my shelf somewhere behind me. Let's see. All right. Well, I think made it through a good number of the questions. I think I've been able to talk about what I wanted to today. I don't plan on having a new blog post this week. despite the active storm that'll come in on Thursday. It's possible, or actually I said Thursday. I'm actually not. Let me double check that I said the date right. Let me see. Yeah, it looks like it's going to come through Thursday into Saturday, actually. So Thursday in Northern California, Thursday afternoon in Northern California, and then Southern California Friday into Saturday with some lingering showers and thunderstorms elsewhere into the weekend. So at some point in that window, I might do an extra. Session later this week to talk more just briefly about the actual storm pattern, if there's some interesting thunderstorms, or if there's a higher likelihood of some isolated severe storms or something like that. So I'll keep an eye on that. Otherwise, social media. I'm increasingly online everywhere, if that's possible, even more so than I used to be. High bar, I know, but somehow I'm even more visible than I was. So you can find me at pretty much anywhere. Although my Instagram account is only for cloud photographs that I've taken, so don't go there for science so much. But that's where the cloud photos live. Other than that, thanks for joining me, and I'll see you next time. We'll probably have a regularly scheduled session sometime next week, but as I mentioned, I might end up doing some sort of pop-up session on Thursday or Friday this week, depending on how the pattern goes. So keep an eye, and if you want to be notified about these sessions, you should subscribe. By the way, one thing I have noticed is that first of all, the attendance of these office hours is a lot higher for episodic storm and wildfire based sessions versus my climate change discussions. And like today, that's a healthy. We've steadily had about 100 to 150 concurrent viewers, which is pretty good for a live stream. But the live events during major storms and wildfires have been well over 1,000 concurrent viewers. So it's an interesting gap. I get that there's a little bit more interest in me being a little bit more like a journalist or an on-air meteorologist during some of those events. But I'm going to challenge people who are watching and folks who sometimes are more inclined to participate in the episodic weather-focused sessions to attend more of these ones. I may be preaching to the choir, given the setting right now, but try and share these sessions with folks who might be interested mainly in the weather piece, since one of the things that I do is I really try and bridge divides between weather and climate, both on the scientific side, the professional side, and also in society and with people and individuals. And so I think one really good way to do that is to have weather folks join the climate sessions and vice versa. So let's try and ramp up the interest in these climate-focused sessions and get the viewership closer to what the weather and storm-focused live radar view type sessions are in the meantime. So yeah, share the channel. Share these events when they pop up. Subscribe, just if you want to be notified. That's one way to get notified when these come up, because some of them are scheduled, some of them are a little bit more impromptu. That's a way to make sure you never miss one. But thanks for that. And I'm going to, again, as I mentioned earlier, work on finding times that are that we rotate through a little bit so we can capture folks at different times of day, and people who are busy during the day, maybe viewing an evening session and vice versa. So that's the plan. Spread the word. I'll be here. All right, talk to you next time.